Hi, this is a quick video to show you how to generate structured text using large language model and your typical inference pipelines. Now, generation of structured text using large language models is quite an issue. You can give them a fairly thoughtful prompt and they will of course respond with whatever information you asked for. But if you ask them to put it in a structured format like a JSON schema or something, the the result can be that information and a lot more, or the JSON packet being poorly formed in different ways. Um, and this leads to a lot of issues, specifically if you are making this piece of code a part of your agentic workflows. So in this video, we will cover how do you use constrained token generation using some of the typical frameworks like outlines, guidance, formatron to generate the exact answer with well-formed regex or JSON schema that you have provided the large language model to respond with. Before we go any further, if you are more interested in the details of how constrained token generation works, I will put a link to the blog post that I did on the subject down in the comment section below, and you can have a look at that and then return to this video. All right, with the preliminaries out of the way, let's look at this notebook. It's divvied up into 5 sections. The first, you do the importing of the appropriate libraries. We're going to use transformers from Hugging Face to test this out. We want to keep the specific parameters that we test each of the prompts against constant. And so for most part, I'm defining them as globals over here. And then we run through the initializations and then get into our experiments where we try to generate the JSON. To run our experiments, we will use the Llama 3.2, actually 3.1, with 8 billion parameter model. This is essentially the same model that 3.2 billion vision and instruct model is built on. Only there is a layer for vision that has been added on. And the reason why we want to use the 3.1 billion model is also because some of the libraries that we are going to use later for doing constraint generation, they are not very well integrated with these multimodal models. All right, so let's initialize everything and load our model. So we're working through that. For our first experiment, what we will try to do is generate JSON using a very standard and a reasonable prompt. So the prompt basically says, generate a video game character, generated using JSON format below, and then we give the format that it should have a name, and then the name for the character, and an age and an age for the character, and then this is where ideally it should give the response. So let me run this, and takes a couple of seconds. And you can see that you're generating the response, which in itself is quite reasonable, but then you're generating a whole lot of other text as well. So there are, of course, you can make this work. You can basically filter out this specific JSON, but you also have to take into account that if you play around with the temperature parameters, then what you might get is somewhat different. You're also wasting a lot of money and energy generating all these other tokens that you will eventually throw away. And that's not really environmentally friendly. It's not really cost conscious from the point of view of your company's budgets. So ideally, you want to generate just this response and nothing else. For our next step, then we say, okay, let's try to provide it a little bit more specificity. And here we do that by saying, generate a single character only and nothing else, and provide the response below. So we'll let that run. And again, you end up with the actual JSON, but a whole bunch of other stuff all over again. Now, some of you guys might say that I can actually already adjust for this using just the temperature. I can make this a lot more specific by lowering the temperature so there is not a lot of room for creativity. I think that's a good way to go about it if you didn't have any alternate tools. But one thing to consider is that really what you want is that the model should have very constrained creativity in the parts where it is given a structure, and then you might want to enhance creativity in parts where it is not given a structure, where, so the structure of this JSON with the opening braces name, it should not have that much creativity, but it should have all the creativity that it needs to function properly in this place where it is actually generating the name. All right. So another experiment, you can say, okay, we're not going to be very verbose. Maybe we'll give it like a very succinct set of instructions. And we do that by saying, create a video game character with name and age in a JSON format, and then just basically open brace. So let's see what this gives. So it's running. So now it did create just a character, but then it created multiple versions of this character. And the reason why, again, you're seeing it create the same character over and over again is because maybe we set the temperature low enough that it didn't have that much room for creativity. Either way, what we would like for it to do is not really generate these many copies. And then here is some cleanup script that I wrote where it's supposed to sort of just pick the first of the JSON characters, or basically pick just this and anything that matches JSON schema. I didn't do that too well, so it sort of cleans up this first thing, but then lets the other part still stay. All right, now let's get to outlines, which is one of the libraries that you can use to generate or do constraint token generation. All right, to use outline, what you need is basically Pydantic, and you define the JSON associated with what you want to generate using the Pydantic schema. Now, that's not what you necessarily need. That's if you want to do JSON using Pydantic. Here is the documentation on outlines, and there is like a whole wealth of things that they enable you to do. You can do JSON, you can do regex, etc. And if you go into the specific documents, you can figure out details about how do you do structured generation, what kind of samplers you use, what are the models that it integrates with. There's really a whole host of things that is available. I'll just do a very small fraction of that. All right, so we've defined a character with a name and an age. There are multiple different ways to initialize the models, but basically what I'm going to do is I'm going to use the model artifact that we created over here using our global variables for both model and tokenizer, and then feed that to the outlines class. We'll go into this a little bit more, but they create their own sampler class. Ideally, I would have liked for them to just use what's available in transformers and extend that. I can see why they're doing this, but the integration is not quite complete, so it's a little bit it's a little bit challenging to work with it sometimes. For example, lack of integration with multimodal models makes us unable to use the 11 billion parameter vision and instruct model. So if you were to use that, that would break, even if you did that without the vision head. All right, so you initialize it, we give it a seed just to make sure that this is repeatable. And here we are initializing the outlines model, sampler, and the generator. And then basically, this is the prompt. Create a video game character with a name and an age. So simple, succinct, short. You can see the response from the previous run. And it created Lily again, of course. Luna. Oh, I realized that I'm not feeding it the seed, so it's giving me different names as I rerun the parameter, but you can see that it's giving you a very structured JSON, quite aligned with what you wanted. So yeah, that's how you do it. And then in addition to outlines, there are a few other libraries that I have explored. There is one called Guidance by Microsoft. uh, so this is an interesting library as well. It works with transformers. It focuses a lot on models that have come from Microsoft. So basically the GPT and the Phi uh, uh, models. So the integrations for those seems a little bit tighter, but pretty good library overall. I saw this other library called Formatron, which instead of trying to develop the entire inference pipeline, it just does the constraint token generation, and you can sort of fit it wherever you would like to in your pipeline. Really like their approach as well. I think feels a little bit more nascent, but pretty solid work nonetheless. So here are a few options, and yeah, let me know how it goes. And if there are any questions that you have, definitely reach out.